So today we're going to talk about what is fission, what is fusion. First, I'll start it off. Fission is in nuclear chemistry. Nuclear fission is either a nuclear reaction or a radioactive decay. The process is the split of an atom into smaller parts. The fission process produces free neutrons and protons. This releases very large amounts of energy by energetic standards, or radioactive decay. That's fission.
Fusion is a nuclear reaction in which atomic nuclei of low atomic number fuse to form a heavier
Excuse me,
nucleus
breaking news.
with
So,
the release
breaking news, I just said breaking news. We just got some breaking news of some gamma rays. Moises, I'll send it back to Moises. Moises, can you hear me?
Hello? Vince? Vince, can you hear me? Vince.
We're on here.
Oh, breaking news. Gamma rays are a type of radioactive decay, and they're very dangerous.
So tell me, why are they so dangerous?
Well, Vince, they're dangerous because they have no mass. And since they have no mass, they can penetrate through anything. Only thick, really thick blocks of concrete can hold it on.
Alright. How does this apply to the real world?
That's why when you go take x-rays, they put a lead vest on you. That way the radiation doesn't seep through and you could get sick or possibly worse.
Well, we just got some new information on alpha and beta particles. So we can go to Derek for this new information, this stunning information actually. Derek, you're up.
Thank you, Vince. Today we'll be talking about alpha and beta particles. We'll start off with an alpha particle. An alpha particle is very similar to the nucleus of a helium-4 particle, which means it is composed of 2 protons and 2 neutrons. Out of the 3, alpha, beta, and gamma, alpha would be the weakest, which means it can't even penetrate through this thin sheet of paper. And now onto the beta particle. A beta particle is 2 particles emitted from the form of radioactive decay for beta decay. Out of all 3, the beta would be the second strongest, which means it can penetrate through this thin sheet of paper, but it can't penetrate through a thin sheet of wood.
Man, that was a heartwarming story. What do you think, Bobby?
I agree.
Alright, well, in other news, we have a special report going live to Justin. Justin, you're up. Justin. Alright, yeah, you're up. Right.
Okay, Vince. I will be talking about nuclear reactions in terms of numbers and equations. Earlier, Moises talked about gamma particles. Gamma particles have no mass. So as you can see in the bottom equation, the reaction on one side of the arrow should equal the other side. And seeing that gamma has no mass, the substance over here should be the same numbers as over here. And as Derek talked about alpha particles and beta particles, you could see the mass of the alpha particles and the beta particles equal the mass put together as the substance before the arrow. Thank you.
Alright, well, this concludes another newscast of LR News on nuclear chemistry. My name's Vince.
My name's Bobbi.
Peace to the motherland, Africa.
Hi.